Hi guys, so today we'll start with the new question number 14, which is to write a Python program to store first year percentage of students in an array. Write a function for sorting this array of floating point numbers in ascending order using first of all the selection sort and then the bubble sort. And then we have to display the top 5 scores in this percentage area of percentage. So let's just copy this question and move on to our text editor. So let's just paste the question and save this file. So let's just also comment this so it won't interfere with our code. So now let's just see what we have to do and how we can approach. So first of all, so let's just assume we have a list of 5, 8, 3, 2, 1, 15, and this would be a random list. So here we have to search for an element. So as in the last question we have shown, we can use linear search or the binary search, or there are more modified versions such as sentinel or ternary search, but for now let's just assume binary is the best solution we know. But whenever we try to apply a binary search, basic condition is that the list should be sorted. Means each of the elements should be arranged in such a way that it is either increasing or decreasing. So kind of here 5 is less than 8, 8 is greater than 3. So here we are getting a mismatch. Either it has to be decreasing or increasing order. So if we try and find out the sorted list of this, then we get 1, 2, 3, 5, 8 and 15. So this is the sorted list on which we can then simply perform the binary search and we can easily find out the element in n log n time. So basically the process of conversion of random elements, randomly ordered elements into either decreasing or increasing order, are also called as sorted order, is called this function, this process is called as sorting. So basically we have to sort this thing. So here let's just take the same example and try to sort this thing. So for sorting, what I can do is I can search for the minimum element in this list and put it at the first position, because we have to start from low to high. We are doing this in increasing order. So then I have to find the second minimum element, which is 2. Similarly, we have to find the next minimum, next minimum, next minimum, and the next minimum. So slowly we get the whole array as a sorted thing. But how can we find the next minimum? First minimum is an easy process that we can use a for loop. But then how we can find? So what I can do is I can remove this one from this list and then check for the remaining list. So like this, I will find the next minimum element. So I can then remove 2 and then check for the same element, check for the minimum element in the remaining list. So here what I am doing, I am taking the minimum element and storing it somewhere, because I have to create this as a sorted list. So I have to store this somewhere. So what I can do is whenever I get the first minimum, I can put it in the first position. Then for the second minimum, I can put that in the second position. And similarly, each position will be changed and our list will get sorted. For example, if we again try how we can do this. So let's take the same example and try to think how we can work on that using the previous approach. So here I can find the first minimum element, which is 1, and then I can shift that to the first position. So now the list will become 1 and the remaining all elements. So now I can assume that this part of this list is in sorted order and the other part is in unsorted order. So I can again implement the same thing of finding the minimum in this part of list and again putting it to the first index. Again the list will be decreased and again finding a minimum element and then adding it to the next position. So like this we can do. So let's just try to do this on a new list. So as we saw, we first find the minimum element and then we shift this to some appropriate place and then say that part of the list is sorted. So here we can keep a pointer which would point the part, or which would separate two parts. So the left part of this pointer would be sorted list and the right part would be unsorted list. So whenever one will be added here at the 0th position, so I can say pointer is here, this all right part is unsorted and the left part is sorted. Similarly, next element 2 will come to this position and now the list will become sorted, list would become 1 and 2. This is sorted, the pointer would go to the next element and this whole part is unsorted again. So similarly we can do this thing and at last we would get a whole list which would be sorted. So here we are going to the 0th index and pointing it and saying the left part is sorted and right part is not sorted. Then finding the minimum element, which in this case is 1, and then we are swapping it with that position. So why are we swapping? If we try to shift the element, then we know each element has to either shift it to left or right. So if we consider the worst case time complexity, then for shifting each of the element one place right, it would take order of n time. So instead of shifting, what we can do is we can swap that element because it won't affect the list. Why? Because we know the minimum element would come at the first position and other element will automatically get arranged as we are going further. So going to the first 0th index, we swap, then we increment the pointer, we go to next index, then again check for minimum element, then again we swap, again go for next element, swap, swap and swap. So we stop here at the n-1th position. Why? Because let's just assume this whole part is sorted. So 1, 2, 3, 5, 8. So this part is sorted and last element remaining is 15. So as we know, these n-1 elements are sorted somehow. So this whole part is sorted. Then there is no need for sorting this last element. As we can say, n-1 elements are sorted, then no need for sorting the last element because it will be automatically sorted. Why? Because if, let's just take example of 5 students of increasing height. If the heighted member goes to the last and short members comes to the first and goes on in the increasing order, then the last member which is left, he don't have to change his place. Why? Because he is tallest and he is standing at the right position. Why? Because in front of him, whichever children were there, they are in the correct position. So there is no need of changing of the last heighted member's position. So similarly, in the last case also, we don't have to check for the n. Why? Because we can say if n-1 elements are sorted, then automatically the last element is also sorted. So let's just try to implement this thing in our code. So let's just go to the text editor again. So let's just create a function called as selection sort. So the thing we just saw, in which we select the minimum element from the list or from the part of unsorted array, we select the minimum element and shift its position. So this thing is called as a selection sort algorithm. So let's just take some parameters. First of all, the array or the list, let's just take A. Then we won't require anything. So we would only require the array. So what we have to do, we have to go for each index up to n-1. Why? We consider that index as a pointer and the left part of that pointer would be sorted and right part will be unsorted array. So let's just take a for loop. So for I in range, so we will go up to length of A minus 1. Why? We just discussed. So last element will be automatically sorted. So for I in range, length of A, length of array minus 1. So what we will do here is we will consider the min index for start would be I. Let's just consider the first element is the minimum element for now. Then what we have to do, we have to check for each of the element in the unsorted array. So for j in range, so the range would start. So let's just move on to this thing again. So here currently we are at the 0th index, so we'll start from 0, but after 0, if pointer moves 1 point ahead, then we have to start from that index because left part is sorted. So at whichever I position we are, we have to start from that up to end. So from ith position up to n, so we have to start from I. So here therefore we will start from I up to the length of the array. So we will start from I, which is the pointer with separate sorted and unsorted part, up to the last element, because that all part is the unsorted array. From that we'll find a minimum index, a index which represent the minimum value in the unsorted path, so that we can swap then. So if array of minimum index means the index which we have assumed has the value greater than a of j, means any value in the unsorted path. So what we can do is we can modify the minimum index to j. So at the end of this for loop for j in range I to length, so for this loop we would get an index such that it is the minimum in the unsorted path. So whenever we get this minimum, we can then directly swap this with the ith element. Why? Because I is the pointer. So we have considered I as a pointer, so we can directly swap. So instead of using the swap function, I will use the tuple unboxing. So it is kind of a way with which we can swap the elements. So let's just do this and let's just try with an example. So a equal to, let's just list some random elements. So let's just take these elements and implement selection sort. So selection underscore sort and then a. So let's just print a before and afterwards. So print unsorted array and then the a. Similarly, after selection sort, we'll print the sorted array. So let's just execute this and see. So at first the same a is printed, which was randomly ordered, but after performing selection sort, we can see the whole list is sorted in ascending order. Similarly, let's just print each step so that we get an idea how is it working. Print a. So here we can see at first for the first position, what we did, we swapped the 7 and 2. So 2 was the minimum element, so it came at the first. Similarly, for the second loop, 3 was brought from the last index to the first index. Similarly, then 4, 9, 7, 10 and 5. So for each of the elements, we swapped and created a list. So we are basically printing each of the step. So this is the basic working of selection sort. So why is this called selection? Because we select a minimum element and then arrange its position, and then we can separate out which part is sorted and which part is not sorted. Therefore it is called as an selection sort algorithm. So similarly, now let's just see what is an bubble sort. So let's just take some values. So let's just take these values. And now, so the second approach for sorting this array would be, we will first of all compare two adjacent members whether they are in this correct order or not. So 1 and 3 are in correct order or not. So we will check the first element is less than the second element or not for the increasing case. And similarly, if we have to decrease, then we can just check if first element is greater than second or not. But now we are implementing for increasing function. We can check whether the first element is lesser than the second element or not. So for 1 and 3, this holds true. So we have to do nothing. But now for 3 and 8, we will again check. So this is also correct. 8 and 9 is also correct. 9 and 7, here we get an issue. 9 is greater and 7 is smaller. So what we can do is we can swap this. So we can swap 7 and 9. Why? Because we have to make this whole list in an increasing order. So for making increasing order, smaller elements has to come to the left side and greater elements has to go to the right side. So similarly, after this swap, we will again check with 9 and 4. Similarly, this is again creating a conflict. 9 and 4 should be swapped. So we swap these elements. So 7, then 4, then 9. Again we will check with 9 and 10. So this is in correct order. So there is no changes. At last we will check with the 10 and 5. So 10 and 5, here we are again getting an issue, conflict. So we will change, swap. So 5 and 10. So currently if we see the list, 1, this would be 3, 8, then 7, 4, 9, 5 and 10. So this is our list after the first iteration. So here what we are seeing, the maximum element is automatically getting at the last position. So 10 automatically got at the last position. Similarly, now we can say this much last part is in sorted order. As in the last case, we selected the minimum element and put at the first position and said it is in the sorted order. For now what we are doing, we are comparing each two adjacent values and swapping depending on the condition which we are checking. And at last of this iteration, we are getting the maximum element at the last position. Then what we can say, this element is sorted. Similarly, for the next iteration, 1 and 3 correct position, 3 and 8 correct, 7 and 8 wrong position. So what we have to do, we have to swap. So let's just copy this thing and do the further step in the next page. So here 10 was in sorted position. Now we have to do for the second iteration. So 1 and 3 correct order, 3 and 8 correct order, 8 and 7 wrong order. So we have to swap. Then 8 and 4 again wrong order. We have to swap. So 4 and 8. Then again 8 and 9. So it is in correct position. So no swapping. Then for 5 we have to again check. 9 and 5 is conflicting. So we have to swap the elements. So as we know 10 is sorted, no need to check with it. So here now in the second iteration, what we are getting the second maximum element. Similar to the last case in the selection sort, we can say these two elements are now in sorted order because we are checking the maximum elements. So similarly, now the list becomes 1, 3, 4, 8, 5. Similarly, now this check will be done 1, 3, 3, 4, 4, 8 and 8, 5. So here 8 will be swapped with the 5. So now the list becomes 1, 3, 4, 5, 8. So we will go on continuing. But here as we can see 1, 3, 4, 5, 8, 9, 10. So this is sorted order. So here as computer doesn't have any idea, we have to go on continuing up to the last step. So how many times we have to do? We have to do for 10, 9, 8, 5, 4, 3. Similarly the n minus 1 times. Why n minus 1? Because as in the last case we said, if n minus 1 elements are sorted, then the last element will get automatically sorted. We don't have to do anything for that because this last element will automatically get in the correct place. So most of the concepts in the sorted order feels the same, because selection and bubble sort works kind of same, but just the position or changing, or how they change, or how they check the elements is different, but both are performing the same thing. They are sorting the element. So let's just move on to our text editor and code this thing too. So instead of selection, let's just print bubble, and let's just create a function for this. Define bubble sort. It would take an array, and so here we will take a for loop for I in range, and range would be up to the length of a. So basically we will be going to the length of a, and we will be go on swapping. So this would start from 0 and up to length of a, but here in the last condition the length of a is, let's just first implement. So what we have to do, if a of I is greater than a of I plus 1, so what we have to do, we have to swap. So a of I comma a of I plus 1 equal to a of I plus 1 comma a of I. So we are basically using the tuple unboxing to swap the thing. So here what we are doing, if the first element is greater than the second element, then we have to swap. So we are basically swapping that. But here when we are ranging from I to length of a, so what will happen, if we consider the length of a, it is kind of for this element 2, 4, 6 and 7. So currently the length is 7, and this for loop will go up to 6. So this index will go up to 6, but there isn't any 7th index. Why? Because list start from 0th element. So here instead of going up to 6th element, we have to go one value less. Why? Because we will be starting from 0 and checking for these two elements, then for 5 and 4, then for 4 and 9, then for 9 and 2, then for 2 and 10, and then for 10 and 3. So we have to stop at this last second position, which is length of a minus 1. And then what we are going, we are doing this swap thing, and we have to do this swap thing for n times, because for each of the elements we have to do this swap thing. So for j in range length of a, kind of n is the length, so for n times we have to do this n minus 1 work, means swapping. So let's just say this whether it works fine or not. So here 7 5 4 9 2 10 3. So this was the unsorted array, and we got the sorted array. So let's just print this also in each of the step. So print a. So here we can see at first 7 and 5 got swapped, then 4 and 7, 2 9. So let's just print this for each for loop. So here at first 5 and 7 got swapped, then 7 and 4 got swapped, then 7 and 9 was correct order, then 9 and 2 got swapped here. After 9 and 2, 9 and 10 was correct, then 3 and 10 got swapped, as we saw in our discussion. So this works as same. So here also at first we swapped for the 9 and 7, then for 9 and 4, then for 10 and 3. Kind of this example is different, but we are working with the same thing. So here like this the bubble sort works. So now as we have seen both the bubble sort as well as the selection sort, so let's just discuss the time complexity of these functions. So here first of all we are using a for loop of n minus 1 times. So this is a for loop of n minus 1. So big O of n minus 1. Similarly, inside this for loop we are again using a nested for loop, which is ranging from I to length of a. Means basically we can assume this is also an order of n. It is less than order of n. Why? Because for each case the sorted part is decreasing, but we will consider this as order of n as we are selecting the big O. Similarly, here also we can discard the constant and we can only take the order of n. So external for loop is order of n, internal is order of n, so both together becomes n square. So kind of the big O complexity for the worst case is n square for selection sort. Why? Because internal for loop, if we consider for worst case, it will check for each of the elements and it would take n iterations. Similarly, as we are performing this for n thing, because we don't know when to stop, so we go on performing. So this also external for loop takes n, so n into n gives us n square time complexity. Similarly, for the bubble sort also, we are using a for loop of n times, inside which we are again using a for loop of n minus 1. So kind of if we try to accurately find, it is n into n minus 1, but as we are considering the big O notation, it gives us n square time complexity, O of n square. So both bubble sort as well as the selection sort, worst case time complexity is n square. So this was the basic approach for sorting of the list using selection sort and bubble sort. So this was all for this lecture. Let's just meet in our next lecture.